Hey everybody, in this video we're going to be working on exponential indefinite integrals. If you want to follow along, the links to the companion worksheet, they're in the description below. Also, don't forget to click that subscribe button so you can stay up to date on all the videos we have coming out from the channel. So what we have here is we've got x squared plus e to the x. Now we have two different rules at play here, even though people want to think they're the same. When the base is a variable, we use power rule. So what happens is when we find the antiderivative, x squared becomes x cubed. Now it's not just x cubed. It has to be 1/3 x cubed. Now why do we need the 1/3? Because when we take the derivative, the 3 is going to come down. But there's no 3 here, so that means the 1/3 has to be there waiting to cancel it out. But what about e to the x? Well, e to the x is actually one of the easier antiderivatives because the derivative of e to the x is e to the x, which means the antiderivative is the same. It's also e to the x. And since it's an indefinite integral, we remember to put the plus c. So this is how we find this indefinite integral. So looking at the second one, here we have the quantity 5 minus e to the x all over e to the 2x. Now the thing to remember is that there really isn't a quotient rule for integrals. So what we have to do is we have to take this quantity and break it up. So that is, we have 5 over e to the 2x minus e to the x over e to the 2x dx. Now we want to rewrite this as 5 times e to some number. Now what we can do is, well, there is no e here. True. But you could think of it as e to the 0 power, because anything to the 0 power is just 1. So we take these two exponents, 0 and 2x, and subtract them, and so we have e to the negative 2x. And so here we have x minus 2x, so that's going to be e to the negative x dx. All right. So the antiderivative of e to the negative 2x is going to be e to the negative 2x. However, our coefficient out front is going to be negative 5/2. Now why is that? Well, a lot of people think it has to do with power rule. Actually, it's not. The reason for this is chain rule, because this is an inside function, inside e to the x. And so what is the derivative of negative 2x? Well, it's 2x. And that's going to end up being multiplied down in front. And so this is why we have this 5 over negative 2, waiting there to cancel it, so that when we take the derivative, we get 5e to the negative 2x. Over here is the same thing. Here we have e to the negative x, but our coefficient is going to be positive 1, because, likewise, we think of negative x as an inside function. And so the derivative of negative x is negative 1 times the 1 that's there will produce negative e to the negative x. So then finally we add c. So looking on the next page, here we're going to do the same thing. We're going to break this up into 3 quantities, e to the 2x over e to the x plus 2e to the x over e to the x plus 1 over e to the x dx. So when we subtract our exponents, we get e to the x plus 2e to the 0, which is just 1, plus e to the negative x dx. All right, so the antiderivative of e to the x is e to the x. The antiderivative of 2 is 2x. And the antiderivative of e to the negative x, well, just like the last one, is going to be negative e to the negative x plus c. Because when we take the derivative is going to change sign. Because of chain rule, we're going to bring down the derivative of negative x, which is negative 1. All right. Now for the last one, here we have 3 raised to the x power. Now this is very similar to e, but the base is different. And so the difference is that the derivative of 3 to the x, if I write this over off to the side, The derivative of 3 to the x is 3 to the x, just like e, but you multiply by ln of 3. So the antiderivative is going to involve keeping e to the 3x, 3 to the x, but we're going to divide by ln of 3 plus c. Because if the derivative involves multiplying by ln of 3, then the antiderivative involves dividing by ln of 3. So, thanks for watching. If you liked the video, please give it a thumbs up. If you have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching, and remember, the best way to understand something is to do it.